We next look at the de Havilland Comet series aircrafts. The Comet 1 was the first commercial passenger jet. It was developed during the 1946 through 49 years using technology developed for the military, and it had its first commercial flight in May of 1952 from London to Johannesburg. It is this particular aircraft that you see on your screen, the GALYP, the Yoke-Peter, which held that distinction. Now, the Comet 1 was an outstanding engineering marvel of the day. It had 4 jet engines. It offered a quiet ride compared to the piston engines in those days. They were very fast, 500 miles per hour, which is almost as fast as today. The range was less than 2,000 miles, but they needed to fly above 30,000 feet in order to gain fuel efficiency because they had jet engines. Now, at that altitude, the cabin had to be pressurized so that the passengers could breathe, and the pressure was something like 8 pounds per square inch, about 0.06 megapascals. And the shell of the fuselage was very thin aluminum, less than 1 millimeter thick. So for a year or so, the Comets flew wonderfully. More than 100 million miles were flown. There were 2 accidents in that year, one minor, both during takeoff, but one of them was fatal and killed all the passengers and crew. A flaw in the wing configuration was identified and it was fixed. So the Comets flew well for a year, as I said, but on the 2nd of May in 1953, one Comet, the GALYV, flying from Calcutta to Delhi, crashed just 24 miles from the airport, from 10,000 feet, just 6 minutes after takeoff, and killing all on board. The crash occurred at about 4:35 p.m. And during a major thunderstorm. So the cause was attributed to structural failure caused by severe gusts and over-controlling or loss of control by the pilot. Now, it's interesting to note that an extreme load rather than cumulative damage was identified as a potential cause. Anyway, there was not much public outcry. Some design changes, some structural reinforcements and operational protocol was changed, and the Comets kept flying, very popular, until about 8 months after the Calcutta crash. On January 10th of 1954, GALYP, the Yoke-Peter, the very first Comet to fly, flying from Rome to London this time, near Elba, crashed from 26,000 feet into the Mediterranean Sea. There was some speculation about sabotage. All the Comets were grounded. Extensive inspection and retrofitting was done. And the Comets again started to fly about 2.5 months later on March 23rd. Unfortunately, in less than 3 weeks after that resumption, on the 8th of April, flying from Rome to Cairo, another Comet 1 crashed from 35,500 feet into the Mediterranean Sea, once again near Naples, and the Comet 1 planes were grounded forever. The Comets 2 and 3 did not fly, and the Comet 4 flew again, but never gained the glory. By that time, the Boeing 707 was found to be much better, and de Havilland lost its preeminence, and the passenger jet production by Boeing, Lockheed, and Douglas, they took off in the other side of the Atlantic. Now, after these 2 back-to-back crashes of the Comet 1 in 1954, an intense and an unprecedented failure investigation was launched. And from tests and the study of recovered parts, the origin of the failure was identified as a short fatigue crack that started from a window and caused the fuselage to burst. And it was a violent explosion, which was corroborated by the autopsy of the passengers. Now, metal fatigue was already known to be a problem. It was known for almost 100 years at that time, and was duly considered in design by the current standards of the day, because the cabin would undergo repeated pressurization, depressurization as the plane climbed and then descended. But the numbers were not adding up. Fracture tests on panels of the same aluminum alloy with fatigue cracks comparable with those found on the recovered aircraft, they failed to correlate with the stress levels experienced in service. So even if the stress razor effect of the window corner was included, it would actually take another 3 years for LEFM, linear elastic fracture mechanics, to be fully formulated, and that happened with the publication of this paper by George Irwin, and in which he introduced the stress intensity factor. So Irwin and others at NRL in Washington DC, they argued that the effective crack length should include the diameter of the window, and using this larger value of the effective crack length, finally resulted in critical stress levels that accounted for the failures. And about 3 years later, Paris and Gomez and Anderson published their very famous paper relating crack growth with stress intensity factor. The following year, in 1962, Paris submitted his doctoral dissertation at Lehigh University. So it took almost 7 to 8 years after the comet crashes to finally be able to relate fatigue with the fundamentals of mechanics. And a comprehensive understanding of what went wrong finally was in place. So during that time, in the mid-1950s, the shortcomings of safe life, the design philosophy prevailing at that time, became clear. And this gave rise to the fail-safe approach. And about 2 decades later, further to the damage-tolerant approach. So this way, the unfortunate comet crashes expedited the development of the field of fracture mechanics, which in turn allowed metal fatigue to finally be related firmly to mechanics after more than a century, rather than phenomenologically. And later, fatigue reliability became an integral part of the design and assessment of machines, buildings, bridges, and all other structures.